In this video I'm going to go through esters for GCSE just as a little bit of a recap to remind you of the structure of the molecules, how we draw them and how we name them. So first of all, you need to remember that esters form via condensation reactions. Now if we think about the word condensation and what we know that means in real life, we might think about water vapour on a window. Now this isn't a time where chemistry is being sort of strange. We are talking about water vapour and water molecules forming. So this is not trying to trick you. We call it condensation because of it being about water. Now during any condensation reactions, and it doesn't just have to be esters, but during any condensation reaction, two molecules join together. And a small molecule, and that's usually water but not always, is lost. Now the H2O is lost from the molecule. We're going to look at how that happens in just a second. Now the functional group that esters contain is COO. Now we're going to look at again why that is in just a second, but to have a look at this and how it might appear in an exam, these are the sort of two different ways that you might recognise esters when they're drawn out. They can have this angled form that we can see on the left, but often they'll be shown as they are here on the right hand side, sort of drawn straight out or at a right angle. Now to make it an ester, what attaches on each end of these is going to be normally C's, okay, and the carbons will have hydrogens around them as normal, etc., but that makes it an ester as opposed to a carboxylic acid. Now to look at how esters form, we're going to look at these two molecules. Now what we've got here is we have an alcohol and we have a carboxylic acid. Now there are other chemicals that can form esters, which I looked at A-level, but at GCSE you just need to know that alcohol plus carboxylic acid forms an ester and water. That's the general equation just there. So if we look at these two molecules, there's ethanol. I've drawn that out with its full displayed formula showing all bonds and atoms. And if we were to draw out propanoic acid, prop has 3 carbons, so there's propanoic acid, remembering that 1, 2, 3, the carbon that has the oxygens on it is part of that molecule and is part of the naming, so we do have to make sure that we include that when we're counting for 1, 2, 3 for prop. Now if we look at these two molecules, what happens is we have to lose water. So look at these two molecules and think, where can we form a water molecule? What is present in ethanol and propanoic acid to form H2O? And what actually happens is that the alcohol, in this case ethanol, loses the OH off of the end of the molecule and joins with an H from the end of propanoic acid. Now if you think back to when you might have looked at acid reactions for chemical reactions in the chemistry GCSE course, propanoic acid is a weak acid and will lose that hydrogen that I've highlighted just there. That is what causes propanoic acid to be an acid. So if I redraw these molecules without those bits I've outlined in red, we end up with this section, the ethyl section. Now it is not ethanol anymore because it doesn't have an OH, and we call this sort of section of a molecule ethyl. Now this doesn't exist on its own because there's nothing attached at the end of that bond. That bond can't just be dangling. We do call them dangling bonds in chemistry. So we've got to add something else to the end. What we're going to add onto it is this other part of the molecule that we've got from propanoic acid. Now I've flipped this round here, okay, so I've just moved the COO to the other side. So it's just a mirror image of itself now. And here is where the H would have been. As I said, we've got rid of that. And we've got this section of the molecule that this is now called propanoate. Now propanoate is what we refer to this little section, propanoic acid that has lost an H. This is actually known as the propanoate ion, which again is a bit more A-level than GCSE. So what happens with this chemical reaction is that those two molecule parts actually join together and we get this ester called ethyl propanoate, and that molecule altogether is called ethyl propanoate. and then water is formed as a side product, H2O, from the bits that we labelled in red to begin with. So just as a bit of a recap there of the naming, okay, ethyl is the part of the molecule that came from the alcohol, and then propanoate is this chunk here that came from the propanoic acid. So the alcohol part always ends in -yl from -ol, and propanoate came from propanoic. So both of them have propano. So the way I remember it is that the O8 has the O's. So the O8 has the O's of the molecule. And that's how we'd count 1, 2, 3, prop, and then propanoate, because the O's are attached to that part of the molecule. So to have a look at an exam style question, I've got one here. Draw and name the ester formed when butanol and methanoic acid react. Now actually I'm going to put my chemicals, I'm going to highlight those just because it makes it a little bit clearer, I think. So we've got butanol and we have methanoic acid. So when we're approaching this, the first thing we need to do if we're looking for the ester is we've got to draw out these the alcohol and the carboxylic acid. So butanol, but first of all means 4. So 1, 2, 3, 4. Now it's butanol, so all of these carbons are joined with single bonds. And then the ol means that we have an alcohol, so that is an OH group. So we've done butanol, that's all parts of the name. So I've then got to put 4 bonds around every carbon and add hydrogens onto the end there. And that gives us butanol. And then methanoic acid, meth means that there is 1 carbon, and oic acid means that we have a carboxylic acid functional group, which is COOH. Meth, 1 carbon, methanoic, carboxylic acid, so the last thing we need to do is 4 bonds around the carbon and add a hydrogen, so that's methanoic acid just there. Now if we think about what has to happen, the OH from the alcohol is lost along with the H from the carboxylic acid. And so if we redraw what we're going to get, there's 4 carbons there. We'd have hydrogens on the end of all of these bonds. Worst bit of organic chemistry is drawing all the hydrogens. And then on the other end here, we'd have the bit of the molecule that we've drawn just here, but without that hydrogen. So I shouldn't have drawn that bit there. And that is that chunk that we have just here. And so that is the ester that we'd get forming. Now in terms of the name, this molecule here was butanol. So this section that we've got here will be butyl. And methanoic becomes methanoate. The alcohol is always the -yl. So that would be butyl methanoate. Second type of exam question, they could give you an ester like this one. So name the ester shown and state the names of the 2 molecules that react to form this ester. So what we've got to look for here are the sections of the molecule. So as I said before, the O8 has the O's. That's really important. O8 has the O's. Okay, remember that bit. So we need to find this ester group. So use the highlighter instead of the pen. So here's the ester group, and then the O's are joined to a carbon chain. So the carbon that they're actually joined to is part of this carbon chain here. So I've highlighted in yellow there the O8 part. Then the other section of the molecule here is from the alcohol. That's just the carbon chain on its own. So if we look at the alcohol first, because that does come first in the name, and then afterwards we have to put the carboxylic acid, because it will be something -yl, something O8. That's what esters are. So it will be something -yl, something O8. Okay. So in green, we've got 2 carbons. So that will be eth, and that will be ethyl. That's the green section there. And then the yellow section is the O8 part, and we've got 1, 2, 3, 4, 5, 6 carbons. So that will be hexan O8. Hex for 6 carbons, an for single bonds, and then O8 because it is from carboxylic acid. Then we can go further and we can name the two molecules. Ethyl will be from ethanol. Remember, ethyl ends in L, ethanol ends in L. And then the hexanoate comes from hexanoic acid. So O8 becomes oic acid. Let me know if you have any questions, either a comment or a message. This is quite difficult as it overlaps with A-level, but there are just some simple rules to follow. So IL from ol, O8 from oic acid, break it down and look for the parts of the molecule.